Thanks for coming, everyone. Welcome to Smith & Wollensky Steakhouse. Serving staff will be going around with the... Wait, that's a different... All right. Anyway, you're all here hopefully to learn something about NetBoot, or you fell asleep before and didn't get up yet, so just stay now, because now I started. So what we're going to talk about today here is a little thing that I hacked together, and that's probably being kind to hacking everywhere. Running NetBoot servers without Macs. It sounds like magic, but somehow I figured out how to do it, and I'm kind of hoping to share it with you guys. So a little bit about myself. Forgot my mnemonic slide this time. Anyway, my name is Pepijn Bruienne. I work at the University of Michigan. These are some of the many ways you can reach me. I realized I didn't put my Bitbucket account on there either. It's somewhere at the end. It's also where you can get BSDPy, so hang in there. That's fake box art. There's no box, and there's no art. But I figured it needed something, so there you go. Looks pretty cool. Has a fewer buttons than that, but anyway, so as I said, work for the University of Michigan, go blue. I have a very long job title, Mac Development and Operations Specialist. I'm a senior. I don't know why they call me names like that, but basically it's sort of an unofficial DevOps type of role, but not really, but at the same time kind of is. So basically I write tools that help in the operations of our Mac management infrastructure. We use Monkey, wrapped our own web management tool around that called Izzy. We might at some point even present that, but since I don't write it, it is up to my coworker to actually put that in gear. But we're also rewriting it right now, so there's a good chance that once we have 2.0, we might be able to open source it possibly. So we switched, as of a little earlier this year, we switched to running Docker in production on that. It's a pretty self-contained set of tools. The NetBoot service is one of those. Our web end is, back end is running on it as well. 5,000 plus users. We're more than that. Probably should have updated that a little bit. We're closer to 6,000 now, I think. We're doing a sort of a centralized IT migration where all units come into our service, so we're still growing. Worldwide, meaning we have, since we're a university, there's users always traveling abroad, so we need to make sure that we service them as well. And another key point is that we, at this point, are not using any OS X server for any of our services, so we're all Linux-based by decree. That is mostly Red Hat Enterprise Linux 7, which I will say nothing else about because there's nothing to say about it. So some of the things that I've contributed to the MacAdmins community, BSDPy that we're talking about today, open source, NetBoot Server. I've also been hacking away on something called AutoNBI that I started sort of as an internal tool to programmatically and from the command line create the NetBoot images that we use for our various in-house tools. That has recently become more of a useful tool for others since Graham Gilbert wrote Imager, which is very similar to our imaging tool in that it's very lean. It just does enough to get a machine booted and an image written to it and the Monkey bootstrap created. So that's been used more as of late. So I've rolled in a lot of pull requests and other features. Me and a couple of other folks are have on the Docker Hub, we have a MacAdmins team where we basically any Docker images that we come up with that are useful for the community, we put up there. And I've said the word a couple times now. I kind of like Docker, so I'm just putting in a plug-in for everyone to go check out the DockerCon 2000 videos that are at this point have all been posted. A lot of good content, and hopefully, as I talk about it on and off in this session and more tomorrow morning at 9, where I talk nothing but Docker, it will give you some ideas and some more insight into what is possible, how to get it started, etc. So I just wanted to put that in there. So to the actual subject of this talk. So these are sort of the goalposts that we'll hit today. So NetBoot, why should I care? Some people feel that NetBoot is horribly outdated, and why would anyone use that at all? I hope to make some compelling points there. NetBoot, how does it work? No, really, how does it work? So we will get into various levels of depths of weed as far as how it actually works. I will try to sort of keep it just on the key points of what is important here and why it was important to the project that I was working on. I'll walk through kind of how BSDPy came to be, and then practice. What can you do with it? Like I said, I might not hit 75 minutes of exhilarating NetBoot talk, but I want to leave enough time for you guys to ask me questions and kind of get in, because I can't predict all your environments and all your requirements. So I would love to answer some questions about, can I do this with it? Is this possible, etc. So keep that in mind. So let's get started here. So NetBoot, why should I care? So Apple has had NetBoot around for quite a long time. I want to say of all the things that are around, maybe AFP is a little older, but it's been around since macOS 8, where you could boot classic macOS, and then it's been kept around through OS 10 as of today. It's still in the OS 10 server. The name has, has changed over the years. It was NetBoot Server for quite some time. Now we're calling it NetInstall, sort of giving a little bit of a slant towards the most often used practice for NetBoot Server at this time. So we got NetBoot, where you can boot an entire computer from the network and theoretically work as if the machine was booted from a local drive. Labs, things like that. I don't think a lot of people who here actually still uses NetBoot, a full NetBoot, to do anything at all. Oh, still some people. That's cool. That's cool. So that is still somewhat used, not heavily. NetInstall is the next one. So that is a mode that's used a lot these days. So basically, you boot a NetBoot image that then immediately, or with some user interaction, goes to install software, packages, what have you. And then there's Net Restore, which is similar, but it just basically boots the computer and immediately starts to write an image to an internal drive. And these days you use a system image utility to kind of create those workflows in sort of a automator-like workflow, which works fine. It's Apple provides a decent set of tools to use all these modes in various ways, and they're handy. Very user interface driven. So to automate this and to make it programmatically useful in a larger workflow, it's a little tougher. Common uses for this these days. So we have, I think, a lot of folks, I see there's some NetBoots in use still too. So NetInstall is sort of the operational mode that is used a lot these days. So I put down some of the candidates there, or the apps that are used the most. So obviously DeployStudio. Who here uses DeployStudio currently? See, a lot of people. So that uses the NetInstall mode. So basically, it boots, and then there's an init script, basically the RC scripts that pull up the DeployStudio runtime app, and you get to do stuff, and then it goes to work and it reboots. So DeployStudio lets you do all the various modes that we have these days. I think I can count 3 right now, but there may be in between. So thick, so golden master imaging. I will not ask anyone who still does that, because that's your business. Thin imaging, where you take a just enough of an OS to get the machine started, later pile on your packages and your other configurations. And then zero imaging, where you take a machine out of the box, you boot it into the client, you have a workflow that just installs, Monkey client, your Casper client, your Absolute, what have you, all the various tools that may be needed to then boot the machine. They all basically can do this, all these modes are possible through DeployStudio. A very recent but very promising and very quickly growing project is Imager by Graham Gilbert, who I mentioned before, which is a much stripped down sort of concept of what DeployStudio does. So instead of having, a lot of functionality, run workflows, do a lot of things, it's more constrained to just getting an OS on a local hard drive, bootstrapping it, and then rebooting and letting your management client take care of the rest. That again can do all the various modes as well if you desire. It's still very much in flux, and if you haven't seen it, definitely go check it out. I think I have a link to it. If not, if you search for Imager, I think it's imager.io. I think so. I believe so. So Imager, imagr.io, you will find it there. And it's open source, so anyone who has any contributions or issues, please go ahead and contribute there. And then there's Casper Imaging. I don't use Casper Imaging, but as far as I understand it from having talked to Ben Toms, who writes the Auto Casper NBI, that uses a full NetBoot image. Is that correct? Am I correct in saying that? So it doesn't really matter for what it does. It's similar, but it's very, it's product oriented. It will do everything that Jamf Casper needs to get going. So commercial software there. There's a lot of talk as of late of, a lot of XY is dead. So imaging is dead as well, according to various people who, depending on environments they work in, that makes sense. I think it's a little more nuanced than that. I think that even if your organization doesn't demand that the image that is on a computer when it's delivered is known, I know that shops like, excuse me, like Google have requirements in that the image that gets written is known to them, so it's not just whatever Apple ships. We're cool with that. We'll just assume that it's safe to do. If you don't use that, then NetBoot is still useful for running diagnostics tools. The aforementioned zero imaging, where you do a quick NetBoot, write your imaging or your management client, get going. That is definitely also still a very, very valid use. And then I hear you say, what about DEP and MDM and all that stuff? Isn't that going to be our savior? Yeah, possibly. It's getting there. I'm liking what I'm seeing as Apple plugs away at it and it gets better. But I'm also personally not quite ready to put all my eggs in that basket. So if it works for you, great. But again, options are good. And you definitely will need something when a machine gets reused or recycled to a new user. You're not going to just take it from the one user and give it to another. If you're in an environment where one user gets one machine through its entire life cycle and you never have to recycle, then I would love to get your budget for that, because it doesn't work for us quite like that. And I think, again, it's nuanced for a lot of people exactly how much of a one-to-one they can do. Long story short, I don't think it's going away anytime soon. So let's look a little bit about how does it work exactly. I will go, like I said, into various levels of complexity about this. We'll start sort of at the top level. So as you may or may not know, NetBoot is basically made possible by standard DHCP or BootP, which is sort of a protocol. If that doesn't work on your network, you got some things to figure out. So it basically uses DHCP and specific options that are plentiful to basically hitchhike on a standard DHCP packet and say, hey, I'm a Mac, I would like the NetBoot, who's listening? And it uses DHCP broadcast to do it. So anyone who's listening, kindly reply. So what we got here is a couple of options that make that happen. So in this case, it's the vendor class options here. I linked to the RFC if you're super bored to read it. Otherwise, that's basically what makes all this possible. It's not just Apple that uses this. VoIP vendors use it. Microsoft uses it heavily for their NetBooting. So it's a commonly used functionality of DHCP. And then it has another option where the vendor can do their own encoding of the options that the client and the server are to exchange, and that is governed by some loose standards of how to encode that. Otherwise, the vendor is free to do with that as they will. And Apple has docs. I'll say it again, Apple has docs on this. They are quite good. The person that has been pretty much writing this from the start, Dieter, I forget his last name now. Anyway, he's been pretty much keeping this up to date every couple of years. He'll sort of add to the spec. You can download it there on the Apple open source site. It is a Word document. Apparently, yeah. So, but it's great. It has a start to finish exact description of how the whole thing works, and the source code itself is available too. So it's pretty nice to get started, and I use it quite a bit to get to what I needed to do. So the rough flow is that once DHCP has given the client an IP address, BSDP. Sorry, I'm just running into this like everyone knows what this is. Boot Service Discovery Protocol. This is what Apple named it. This is also where the very punny name came from after I started writing it. Had I written it in Ruby, it probably would have not sound so good. So good thing I did it in Python. So how this works is that once all the negotiations are done, the client should have everything that it needs to ask for the kernel or booter file. You've seen that probably if you use a Mac and you've poked around or you work with NetBoot images, that it can request over TFTP. It requests some other related items through TFTP as well, the kernel cache, boot plist, a few other things. After that's done, it will request the actual OS. Usually it's called netinstall.dmg or netboot.dmg these days. And it can load it over HTTP or NFS. Back in the olden days of classic macOS, it would also be able to use AFP. Before anyone asks, no, that's not currently supported in BSDPy, but pull requests are accepted for that. Once that's done, if you do a NetBoot mount, in NetBoot mode, it can also optionally mount a shadow file for client files to be stored on the server over AFP versus locally to do a full diskless NetBoot. So that's sort of the order of operations there. More you say, I have more. So like I said before, Apple has quite good documentation available about this. So given that document, there's still a lot to understand about the actual protocol, so we shall go deeper. So this is a very simplified overview of how the exchange works. It's pretty much like this in the documentation as well. So how this goes is that preceded by this is the DHCP IP retrieval phase. So the client now has a valid IP address. And the first thing it does is it sends what's called a BSDP inform list packet. It uses DHCP inform, which is yes?
Does it know its boot server yet at this point?
No, it does not. So this is the first step. So it has an IP address. What's next? So it uses DHCP inform, which is one of the modes of DHCP, and inside the vendor-specific options, it sends a code for list. So it sends out a broadcast and says, anyone who's listening right now, send me a list of images you have. That can be one server, that can be 100. It's up to the client to concatenate all those responses into one list and display it to the user. So in this case, we'll say there's one server. So the server now replies back and says, hey, I'm a NetBoot server. I'm going to send you back a DHCP ACK or acknowledge packet, which is another mode of DHCP. And it has the same vendor-specific option that says, this is a list of images that I have. Kindly process them on your end. It sends that a couple times. The client sends a couple requests. The server sends a couple requests. It's up to the client to mash this all together into one list. So there's a bit of duplication, but again, packets may be lost, so it's a good thing to send out a couple requests. Also, some slower servers may take a while to respond. Next phase is the select phase, so that is when either, if you boot a Mac holding down N, it will select what is marked as the default image, or if you pull up the boot selector holding down Option or startup disk in the OS itself, you're telling it, all right, I know what image I want. I'm going to send you another what's DHCP inform packet, but now my vendor-specific option is no longer list, it is select. I know what I want, and this is the ID that you should give me the info about. Server gets that and says, all right, you asked for image 5. I'm going to send you the things you need to know about that image to actually boot it. So I'm going to send you the TFTP path and the path to the disk image that the OS is on. Once the client gets that, it sets up and it goes to the TFTP phase and it starts to load the booter and all the other things that go with it. And I kind of stripped because the TFTP blocks go long and far. But once that phase is over, it jumps to either NFS or HTTP to download the OS image, and things hopefully are on their way. I said there was a lot of info. I have more info. So what does that look like? So I'm doing the highlighted bits of the DHCP packet that are actually of note here. So the DHCP packet that is sent by the client is DHCP option 53 will set itself as 8, which is inform. It then sets a vendor class identifier. You may have seen that, the AAPL, BSDPC, i386, iMac. So basically it says I'm a Mac, I am an Intel compatible Mac, and this is my model ID, which the server can then use to decide what image to send it if it's configured to do that. DHCP option 43 is where all the magic happens, which is the vendor-specific information. There's a couple of bits of info there. I'm just lifting out the one that is important here. So that is the BSDP message type. So there's 3 in total. So this is 1. And that says, this is a list request. Please send me a list of your images. Server then comes back with a lot of the same stuff. You'll see here that the DHCP option is now an ACK, acknowledging the list. The vendor class identifier is shorter. This means I am a server, I'm not a client. And then it says, hey, this is an acknowledgement to your list request. I have this priority. The priority is used if you have multiple servers on your same network. The one with the highest is the one that gets preferenced by the client. So it's a very rudimentary way of determining which server is busier than others. It doesn't really change. So in my code, I randomize it for now. There may be smarter things you can do and actively determine who's busier, but for now, it doesn't mean a whole lot. So basically, it is a number that is generated, and the higher, the more higher priority the server has. Default image ID, so that's if you hold down N on the keyboard, that's the one that will get loaded or requested. And then the boot image list is a variable length bit of data that has the ID, the name of the image in it, and this is a reason to keep your image names kind of short, because the longer they are, that field may overrun and you may run into trouble. So short and sweet works best here. Like I said, select, so a lot of the same stuff. We're sending an inform again, we're saying who we are, what kind of machine we are, and we're saying, we're sending a BSDP code message type 2, which is select. Give me the image that I tell you, it's a number between 1 and 65,535. Kindly give me the image info so that I can get booted. Server then sends the same info. It sends some DHCP options that are new here. So the S name is the server name, which is the IP that the client will use to download both TFTP from and the disk image itself. So it needs that in this case. This is where you can play around if you want to use a different server. As we do in BSDPy, you can point it to a different server somewhere else, like a file distribution point of some sort. Dhcp File is another option. That is the name of the booter file, so it's going to have the absolute path on your TFTP server to booter. The client by itself then uses that path to determine, oh, I also need the kernel cache, which is in this subdirectory. I need the com.apple.boot.plist. It grabs another couple things that you don't have to supply. It knows where to look. You got to make sure they're there, or you run into trouble as well. And then it sends the sort of message type is to, hey, this is an acknowledgement of your select, and again, the boot image ID. I think one got cut off here, but it also has the path to the disk image itself, which is just a string, basically. So when I said this is sort of like learning how hot dogs are made, I agree with you. I had to dive into all of this. So if you have had enough, I did a lot of packet tracing too. I had spent quite some time in Wireshark trying to figure out how all this worked. So it was quite an experience once I looked at how all this was done. So you might ask, wow, this is, yeah, why? Well, it kind of started like any other piece of code that if you have ever written anything, it's good to have a goal. Not to go off on a tangent here, but I found that if you want to learn to program anything in any language really, it's good to have a goal or something you want to do that you feel is not entirely out of your reach, but possibly a little bit. It helps a lot to have that goal and say, all right, well, I have a couple of NetBoot servers that are Macs in my data center. I want them gone, and knowing what I know now, this might be possible. I want to figure out how to get this done. So I had done a little bit of smaller Python, just tinkering and just writing some small tools to do a couple of little automation bits and pieces. So basically I figured, can I cobble together enough Python code to actually fool a random Mac client into thinking that this is a NetBoot server they're talking to. Thankfully for Twitter, we now have a very closely documented history of everything we've done ever. Luckily, this one is positive. November 16th, right around 1 a.m., I had enough code put together that my Mac showed a NetBoot image. That was all I had. I just had a list packet. That was all. But I did a victory lap around my living room. My dogs looked at me. What are you doing? They didn't understand. So baby steps, basically. So I had something, and I figured this might be interesting. The good thing is that there's in the Python world, there are a lot of modules that do a lot of things that you probably never even knew existed. There was already a project, PyDHCP lib, which is basically a Python implementation of DHCP. So I didn't have to rewrite all of that. And I'm fine with not rewriting things that others have already done because it's a lot of tedium and not really, it doesn't get to the meat of what I'm trying to solve here. So I happily use that as my starting point. So one by one, a lot of Wireshark, a lot of packet tracing. I figured out how to get all these things plugged in, figuring out how the various data types were supposed to send some binary, some hex, it's all DHCP is very much a low level, as we know, protocol. But the goal was to get the two minis that were in our data center to unplug them and put them in a corner and never see them again, because those were the last Macs that we had in production use for server use. I'm fine with Macs for virtual machine testing and a whole lot of other things, but for servers, they're not the greatest, unless you buy two. Thank you, that's a plant, everybody. At this point, you need to buy two of everything, so if you want a redundancy, you need to buy two. Anyway, I won't go off on a rant here. Come to my Docker talk tomorrow. I'll talk a lot more about why Macs don't make great servers anymore. So, given that, I woke up. Sometimes I dreamed in BSD packets at some point, but not that much later. About 3 weeks later, I had something going. I had multiple images listed. I could, in a very rudimentary way, boot them. It was a pretty good day. I was pretty happy. This was looking good. So I plugged along and actually felt confident enough to actually put it up where other people could look at it, which is always sort of an unnerving process of putting code out there for others to look at and having others say, well, why don't you do it this way and that way? I just took all of that in stride, if you will. I took any suggestions I could get of improving my code, gave it a name. Like I said, good thing I wrote it in Python, so the name was easily come by, BSDPy. And there's my project page. I knew I included it. So I'm using Bitbucket mostly because I work in an EDU and we get free, private, unlimited repos on Bitbucket. Some people have asked me to move it to GitHub, which I will do in the next couple of weeks. I don't really have any need for this to be private anyway. But so that's where you can go and look at the code. I have a couple of branches there for various implementations of things. So now let's talk about what it can actually do. So some basic features. Basically, my first goal was to feature match Apple's server. So I can serve NetInstall images. Still working on NetBoot. I guess doing a poll here of how many people are using it is a good sort of, gives me an idea of the priority to give that. I see people still using it. So there's just some work that needs to be done that I didn't need, and a lot of this stuff comes down to whether I needed it immediately or not. But others that need it and are able to even if they're not programming savvy, if they can give me some ideas of how they're using it, is very helpful to implement these services. So it can serve all assets from a single host, as the Apple servers do. Filter images by system identifier, so if you have models that need a specific image, otherwise they don't work, like the newer MacBook One and things like that, it will do that. Filter by MAC address, if you have specific machines that you want to boot a specific image, maybe their lab machine, something like that. And then the server priority, as I mentioned before, I just pick a random number because it doesn't seem like Apple has given it much more thought than let's pick a number and move on. So, like I said, if there is a need for a more precise load balancing of this, it's something that can be implemented based on requests from the community. So some advanced features, things that I built in because I kind of needed them to leverage what we already had. So you can serve the actual NetBoot request and TFTP, and then the HTTP and NFS from separate hosts. So if you have an existing file cluster or something that is load balanced or just basically configured to handle file downloads, you can point it to that. There's a flag as well as environment variables that I'll touch on in a minute that will let you set that. So then you can so you can have them side by side. You can also point it entirely to a different server completely where this might be in AWS, for example. So if you have a lot of global clients, you may point it to AWS and say, get your boot image from AWS so that we have proper localization coverage without having to do much. Obviously, make sure that your images aren't 8 gigs to download. Your AWS bill may give you a shock in that case. There's an API tie-in. What that does, I will go into that more, but basically it allows anytime a client checks in, it to check with an API externally and say, hey, this is so-and-so client. Which image should it get? Should it download from a specific URL? Is there a specific image it should get? It's a fairly simple JSON exchange, and if you are particularly interested in that, come see me. I can give you more background. I go into the keys and stuff that you need to use for that in a minute. runs on most Linux distros that have Python 2.6 installed. I've tested it as far back as that. I haven't really tested it with 3. There may be some minor tweaks that are needed. And then as of very recently, it also runs on Windows. I got to thank, where is he? Martin Gilbert helped me a lot with getting that figured out, sort of a back and forth between him feeding me the errors that were coming up and me giving him fixes. So it now runs on Windows as well. So if you have an existing Windows infrastructure that would be useful to host this off of, you can use IIS. And one of the many, I've learned, TFTP servers that are out there for Windows, you can use that as well. So I'm hoping that this is a pretty flexible arrangement. And it actually also runs on OS X. I don't know why you would do that, but there you go. You know. So let's see. So separate hosts, touched on it a little bit. So you are basically looking at having a local subnet that you listen for requests on. You have maybe a TFTP and or HTTP NFS host and another network that is serving all of your clients. You can separate them out. It's helpful if you can't do IP helpers for whatever reason your network team doesn't want to, or you have to explain what the IP helpers are. I've run into that. So you could have one of these BSDPy tiny little instances on all your subnets that are all pointing to the same file server backend, so that you don't have to mess around with IP helpers. You can just drop them where needed, and they all point back to the same backend if there's no real big deal in various subnets all connecting to the one server. That way you could get to skip the IP helper conundrum. So you can also point it to different locations. File servers in different locations. So if you are global or you're restricted in certain locations, you can point specific clients to specific file servers that are local to the client to cut down on inner building or intercontinental data links, and cut down on traffic cost and or slow speeds. One thing to note here is that if you are using a web server, the BSDP client does not know HTTPS. It just simply dies on that. So it needs to be HTTP. So you might want to look at some kind of DMZ type setup where that is possible. HTTPS just dies immediately. Unfortunately, it would be awesome for Apple to add that, but at this point, I don't think we should keep our fingers crossed that Apple will ever implement HTTPS net booting. So then we have the API mode. I'll go into that a little bit more because it may still be a little vague how that works. So how this works is that every time a client sends one of these list requests, it sends a couple of standard items. It sends an IP address, MAC address, and its model ID. The idea is that the API, your API endpoint, when this client checks in, it gets a request with those 3 bits of data, does stuff that is up to your specifications to determine, based on either IP, MAC address, or model ID, or a combination of the 3, what NetBoot image it should get, or where to go for that image. So if you have a way to determine from a database, like let's say your management system has a list of all your systems by location, you can hook into that and say, well, this IP range or this MAC address is in this location. It should get my West Coast file server, or it is, I don't know, it's in Australia. It should get the Australian file server. You can do something like that. So it determines what images it should get, or what location it should get them from, and then it sends the URL to get the TFTP payloads and the disk image payloads separately. And the client doesn't know anything else. It's a very quick back and forth, and the client moves on and it gets its information where it needs to. So like I said, useful to create location-specific or model-specific restrictions, but you get more flexibility in that you can write your own logic, and this can be pretty simple with something like, what have you, on Python, like there's very simple web servers for Python, Django, things like that. If you want to get a better idea of how to do that, come see me later, can talk through that. But the idea is to sort of expand on what the Apple NetBoot Server can do and make it a little more flexible in sort of a modern, a disparate location setup for some folks. So like I said, just to reiterate, 2.7, we'll say 2.6 but 2.7 for sure works. Windows Server, working on that in beta. I hope to have that fully posted in, I don't know, another week or two, hopefully. And then the randomized server priority is there as well. So in practice, how do you deploy this? So it will not be a surprise to you that I have named Docker as the recommended deployment method because I have built the images for you. You can grab the image, inspect it. Don't just trust what I write. I'm not saying I put Easter eggs in there, but make sure that you understand what you're deploying as with anything else. It's an easy way to get set up. All the dependencies are in there. It is set up to basically kick off and go, and you can modify its behavior using some of the variables that I'll go into in a second. Sam Keeley has written a Puppet provider for it that does much of the same thing that needs to be done. So it sets up TFTP, HTTP, I believe, yeah, and pulls the code and basically sets it up. So if you are a Puppet shop, that's useful. URL is over there. Like I said, Windows deployment to follow soon. We're just sort of committing the code changes for that. And the important things to have set up is to know that ports 67, 69, 80, and the NFS ports, depending on which one you want to use, are accessible. Your server needs to be able to listen on those, at least on 67 to get the requests, and then 69 for TFTP, and then 80 or the NFS ports to actually serve content. So is this readable? It's readable, right? Yeah, sort of. The slides will be available. So with Docker, it is a simple. Sorry, I hate when people say it's as simple as. Anyway, it is relatively as simple as doing 3 run commands for your various bits. So first you run BSDPy, you listen on port 67, you run TFTPD, you use the volume that you're already using from BSDPy to serve the TFTP bits, and then you run, in this case we're using the official Nginx build. Nginx is a nice, small, powerful, optimized for file transfer web server that we're also hooking into our local, in this case, local NBI directory where we store all of our NetBoot images. And pretty much off to the races. That is all you need to do to get a BSDPy instance set up on a single host. Linux, you can do it directly on Linux without all this Docker nonsense. It's very similar. You just have to make sure that your preferred distro and HTTPD are configured properly to serve from the directory that you keep your NetBoot images, TFTPD set up, and then clone the code, step into the directory and run it with Python. And the minimal requirements are there. So the path to look at the protocol, HTTP in this case, to use to serve disk images, and the interface to listen on. This may be a different interface. This is for demonstration purposes only. That is all it takes to get a fully working server set up. And once you do that, I don't blame you if you can't read this. This is basically the initial logging output of when BSDPy starts up. So it gives you some stats on the IP it's listening on, the path it's looking for its NetBoot images, protocol it's using, the URL, all the NetBoot images will be loaded from any of the found NetBoot images. In this case, we just have a 10.9 image that is there. And below that, you'll see list and select requests coming in. And you'll see at the bottom there is a client that checked in and that asked for the image by number, and it got back from the server the TFTP path and in this case, HTTP path to the NetInstall disk image. And that is pretty much what you'll see in a log. It'll show MAC address, IP address, model, so a lot of logging, debugging that you'll need to kind of like figure out what's going on with your clients. Thank you. To configure it, these are some of the environment variables that you can pass in. Some of these are doubled up, like interface, IP, protocol, NBI path. A lot of this is aimed towards Docker, but you can use this just the same in a bare install as well on Windows. These are the ones you can use as well. Most of these, so interface are listed on the IP to use. So if you want to use a different file server, you would put the IP of the server to use, protocol, HTTP, NFS, the path. NBI URL is a full URL on a different server that you want to use just for the HTTP bits. You can also use NFS, I believe, but I have not used that a lot. So if it doesn't work, definitely file an issue for that and let me know. The API stuff is basically you give it an API URL, which is the endpoint that it will query with standard HTTP gets. I will go into the keys that it asks for in a minute. And if your API requires a key, you can also pass that in to actually get the info. Diving into the API a little bit, so it does two things. At start, it will send a request for all, which, as it sort of indicates, it asks for all the available images that the API knows about. It uses it to build a list at startup so you can see all the images that you will possibly be getting from your API, so that you can kind of not just see by client, but you can see exactly, this is a list of images that what might possibly go out to my clients. Mostly debugging, but I found it very helpful to have all that info right up start. And then when the client checks in, it sends those three keys that the client provides: IP address, MAC address, model name. They're all strings. Your API basically will need to be able to handle a JSON block and they're all strings. So that's pretty straightforward. Once the API does its logic and has its reply ready, it should send back an array or a list of dictionaries named images, and then each list item should have at least the following keys. So the name of the client, booter URL, that is the absolute TFTP path, so slash, in this, let's say slash NBI slash myawesome.nbi/booter. Then the next one is the root image URL, so that is your full HTTP, not HTTPS URL to your NetInstall. Again, this can be variable based on those three factors that I passed in, so that can be different for clients depending on where they are or what model they are. And then the priority is the image ID. So if you do a lot of netbooting, you probably already noticed, but images between 1 and 1024 are meant to be used by single NetBoot server instances. And if there are more images with the same name with an ID below 1024, they will both show up. So if you have two images that say our NetBoot, they will both show up, and they will have different IP addresses showing to say that they're different NetBoot servers. If the image ID is above 1025 through 4096, they will get concatenated to 1, and it will basically pick which server to load from based on what? The server priority, that's right. So it serves an actual purpose. And kind of how that works is like this. So in the middle you have your BSDPy instance. The client checks in with a BSDPy request, the purple there. BSDPy then sends off an HTTP GET to the API. API comes back with the info needed. the BSDPy instance then sends the info to the client where to get what. In this case, the TFTP booter is coming from the BSDPy server itself, and the HTTP or an NFS boot disk image is coming from an NBI repo somewhere else. This can be a single host, this can be a clustered setup. Just depends on how many clients you think you need to serve. There's more. One thing I noticed in large environments like ours, where there's many hundreds and thousands of clients that may be checking in, the API traffic may get a little, because I said before, clients will send multiple requests. They are not necessarily done once they have a list, because they want to make sure they pick up all responses. So the traffic can get a little heavy, and your API might not necessarily need all that duplicate traffic. So what I did, I have a blog post outlining this in much more detail than I have time to do here. But if you run it in through Docker and you have a Redis is basically, it's a key value store. So it's a glorified plist in that it has keys and values, and you ask for a key and it gives you the value. That is what Redis does. So if you have Redis running and BSDPy recognizes that you have it running by virtue of doing that link that you see over there, if it finds a bunch of environment variables that start with DB, it assumes and checks that it has a valid Redis instance running somewhere. It will store those API responses in Redis with an expiration. So once it sends out one request, it throws it in the key value store, database, whatever you want to call it, and will not make another request to the API for, well, you can tweak it. Right now I have it set for about 15 minutes. So if a client sends a lot of requests, it will get one sent to the API. The rest will be retrieved from the key value store. So that cuts down on about 95% of sort of duplicate network traffic. This may not be useful in an environment that's smaller, where the traffic isn't really a problem. Larger environments, I ran into this pretty quickly, so I decided, let me cut that off at the pass now and make sure that the option is there. Again, if you are interested in using that option, but not quite sure how to do that, fully understandable, ask me on IRC. I have a page at the end where to reach me, or email me, or whatever, file an issue, and we'll work through it. But I've noticed that this helps a lot with cutting down on sort of duplicate traffic. Again, I wish this wasn't in blue, but I have a blog post about it as well. So I just wanted to put that out there. If you have a large environment, I do have your interest at heart here. So you might ask, who is using this crazy thing? Well, it turns out there's quite a few people that are already using it. I put out a sort of belated request for folks that felt like they could share in clear or less clear terms what they're using and how they're using it. So here's a couple ones that I have. There is a small animation studio in Glendale, California that just switched to an all Linux Mac management backend. They're using about 100 clients right now. BSDPy, Imager, Monkey, all on one Linux backend. There is a certain global service contractor that may be working for another big fruit-related company that has about that is going to have about 10,000 clients NetBooting off of this by the end of the year. There's a initiative underway to get all the OS X Mac servers out of there, so this is part of it. There is a certain cloud desktop publishing vendor that makes packages that we all love. That's all I can say. It could be anyone. They use about 7 BSDPy servers, and they used it mostly for lab testing, for testing their products. I'm hoping they also test their packages on it, but who knows? Maybe they don't do that. This is speculation. Don't nail me down on that. So they had about 1,000 lab clients. There's an enterprise logging vendor. Wow, this sounds super generic. Anyway, they're using about 3 BSDPy servers, about 100 clients now. Then we have, I thought this was clients. No, this is actually 2,200 BSDPy servers, because that's how many school locations they have. So I don't know exactly how many clients that is, but I would imagine more than one per location. So let's use safe statistics and say they have at least 4,000 clients running off of that. There's the Whitby School in Greenwich, Connecticut. Rutgers University is now also starting to use it because of the Windows compatibility. So these are just a couple of the highlights, some of the responses I got. I'm sure there's other folks using it, but it's very encouraging to see. It helps a lot having a lot of people use it because I get great feedback of bugs that I'd otherwise never know about because every environment is so different. So it's been very helpful. So I have some more pictures here that hopefully may make it a little clearer. So single host example, I use a container because this is from my own infrastructure, so it's Docker, but just pretend it is a blob. So to recap, basically, clients do the discovery via DHCP. Optional, if you needed, IP helper there on the side that helps reach the BSDPy server. In this case, the BSDPy server does all of the work, so it serves DHCP/BSDP on port 67, TFTP on 69, HTTP on 80, and self-contained, very simple, in single subnets, or if you have the ability to use IP helpers, multiple subnets as well. Slightly bigger setup, so now we're splitting up the HTTP server, so same story here. Client checks in, optionally uses IP helper to get its bearings. The BSDP server now points the S name, which is the purple dotted line there. That is basically saying, for all your requests for this stuff, go over to that server and then ask them for the files you're looking for. So it still gets the booter from the BSDPy host, but now the OS image is coming from a separate Nginx host that may be better optimized to serve a lot of clients. And then this very snake-looking contraption is sort of, it's a recap of what I showed you before, but basically to give you a visual of how this may work. Shouldn't have used black text as labels under that. Oh well, lesson learned. Anyway, the top web server is east, the bottom one is west. Clients check in through various IP helpers with the BSDPy server. They check in with the API that says, well, this one is from the West Coast, so send them to the West Coast. That one is from the East Coast. Kindly go get your boot image from the West Coast file server. That is your local server. I talked a little bit about things you need. So there are some pitfalls with NetBooting. I'm sure, who here has never had a problem with NetBooting? Awesome. I won't ask the other, I think it's clear. So it's sort of a voodoo magic at times, 16 minutes, nice. So subnets are the biggest downfall of NetBoot because it uses broadcast that will not cross subnets, so you will definitely need an IP helper, best case scenario, or as I showed, you can also put various BSDPy instances on your various subnets and then I'll point them to one file server should the need be. But I would definitely try and get your network team to be on the same page and agree that IP helpers are not, I don't know exactly what kind of circle of hell they think they are, but they're not bad. If they understand anything about Cisco IOS, then it can be done. So any kind of firewalling. I run into this at our organization at times. We have units that manage their own firewalls that once had rules put in place that everyone forgot about. If any of 67, 69, 80, or I make a typo in the NFS port, I think so. Awesome. Anyway, the NFS ports, HTTP, TFTP, or DHCP, if any of those are blocked, you're going to have problems. So make sure that there's no firewalling, either outgoing or incoming going on, because that will stop the party pretty quickly. TFTP it can be slow. Is trivial is probably the worst name anyone could have ever given to TFTP because it's far from trivial. It's quite non-trivial at times. What I do on my TFTP instances, I optimize the block size to the most compatible for regular IPv4, which is 1468. You can Google it on, if you Google 1468, the first thing that comes up is a little calculator for appropriate TFTP block size. That's how often it gets Googled, I guess. So that's a tip that will give you the best throughput. If you use jumbo frames, awesome, you can make it bigger, but generally people won't be doing that. Apple's EFI has all of its own peculiarities. Some of the older EFIs may not show anything when you hold down N or Option. You may actually have to hit the N key during the boot selector, and then it comes up, but it will not show a name. It will just show the IP address of the server. This is just something to look out for. Conversely, the newer EFIs, you cannot hit N in the boot selector at all. That's gone. Apple thought, well, who uses that? So that's gone. They also give up very quickly. If your DHCP is slow, you have port fast disabled, some of those other things that sort of delay a link coming up. If it doesn't get an IP very quickly, it'll shut down and it will not query again. It can be a huge pain because now you need to figure out if this port is being delayed artificially or if this is just how it is. But it gives up after about 5 or 6 attempts, and then you're done. It won't work. So something to look out for. If you run into that, you definitely need to check to see if IP responses are coming back quickly. I have 12 minutes. I wanted to show, if I don't have time, I'll try this, but this, you may recognize this. This is a Raspberry Pi. I just, past week, created, I guess what you could call a BSDPy appliance on this. So the idea is that if you are in a network situation where you have no ability to do either IP helpers or anything else, you can put this in a little box, put your NetBoot images on here, plug it in the local network, have your clients find it, do your netbooting, put it in your pocket, and move to the next location. So it's basically a portable NetBoot server. Supposedly, when I plug this into the wired network, it's on the same subnet, but I already saw that there's .0, .6, .5. So honestly, with 12 minutes left, I don't think I'll try this. If you want to see this, I will gladly plug it in somewhere, and we'll put on some prank NBIs, and we'll just make everyone load them. What's that?
They're running bigger than /24.
Oh, yeah?
Oh, yeah, it's all one big subnet. You should be fine.
Die. Okay. All right. Yeah, that's right.
We blame other people.
We'll try real quick, see how far we get.
Yeah.
So you have a keyboard. So to give you some background while this loads, as exhilarating as this is work. There it goes. During the DockerCon 2 weeks ago, there was a group of German hackers, I guess you can call them that. They showed their Docker-specific build of a Raspbian OS that basically is like other Docker-specific OSs that has just enough to run Docker. So I had the idea of doing this, but a lot of work was involved and I just didn't have the time. They kind of made it a lot easier to just load an image on your SD card and you're up and running. So I built a BSDPy ARM image. I built a TFTPD ARM image. There's already an HTTP ARM, because it's a different architecture. Sorry, I couldn't think of the name. So I needed to do that. I've done that part. So if you have a Raspberry Pi, you should probably be able to do that. And let's do it this way. So what I have here already is some previously created images. I need, let's see, I need, oh, there it is. And now, whoops. Don't mind that, that's just SSL warnings. It's not interesting. That's secure. It's the Python build on this platform is just a little more chatty. Well, like I said, no guarantees that it actually will work, but I'm on the wrong network anyway. No, I'm not. Anyway, I think it's running, but like I said, the networking setup may not be of such that we can actually rely on this. Anyway, to give you an idea of what this is downloading, this is using our internal API calls, but so what you can see here, this is a previous run, but so just to get an idea of what this guy has done before, this is hooked up to an API, so it actually caches the TFTP stuff that's given from the API, caches it locally on the TFTP server there, and then the actual disk images are coming from an entirely different HTTP server in this case. And that is what this guy's doing. It doesn't look like this is actually working. Sorry about that. Yeah, well, you will have to take my word for it, like a good magician says. It does work, the rabbit is gone. Basically, I just finished this. I just wanted to give this as this is available, and if you're interested, come see me. It works. You can basically, with a little bit of configuration, you can get this set up to be a tiny little, I think this thing died entirely now. The network isn't exactly the way you expect it to be. But anyway, so this does work. You can put it in a little clear box and have it in your pocket and basically have a portable NetBoot appliance that you can carry around in case you need to plug in somewhere at some site. I would recommend using it with some kind of external HTTP URL so that you always know that, like AWS or something, or something on your site that you know will work, versus necessarily relying on this, because it may be a little slow to SD card to load. TFTP is all right. HTTP can be a little slower. So that is my demo. Anyway, I wanted to show you guys this because I just finished it. 6 minutes. Whoops. Okay, yeah, sort of. How to get support. If you have an issue, file it on Bitbucket. I'm on OS X Server, Freenode, Twitter. 140 characters might not be the greatest way to describe a very elaborate issue, so definitely try to get my attention there, and then let's continue it in other ways. You can email me, of course. How to contribute. If you have even the smallest little bit of, even if it's a syntax error, I greatly appreciate any contributions people make. Open a pull request or ask me about it if you don't know how to open a pull request. I'm happy to put in changes without it as well if they're not 1,000 lines of code. Test it in an environment that I probably can't replicate. There's many different permutations that I couldn't even think of. Find bugs, reports bugs, get bacon, and if there's any support, any feature from a vendor that you would like to have in there, so you can hook it maybe into their API to do all this fancy API stuff, file a feature request. Or maybe there's a vendor that has a current NetBoot Server product that isn't as great as it is possibly made out to be. You can ask them to integrate this instead. I'm just saying. So that said, if you have questions, you have 4 minutes. Wow. So talk fast. Anyway, thank you. Any questions? Yeah.
Does Apple's
Step up to the mic.
Apple's NetBoot Server has a feature that makes the default image that if a client uses an image, it uses that as its default going forward. It's kind of sticky in that way. Does BSDPy attempt to do that?
No, because it's the only reason to do that is to gain some kind of speed improvement that really isn't here. Like it's used for NetBoot. If you have a shadow file in AFP, it uses that to hook them back up together, so it doesn't have to recreate that and use up needless disk space. So
Okay.
wasn't there any real point to use that? So
Okay.
Step up to the mic. You got 3 minutes. Come on.
I'll keep this quick. So this is to follow on the shadow file support. In my own shop, I use NetBoot utility disks,
Okay.
which are full NetBoot environments that use, the shadow files. That's one big reason why I've been sticking with OS X Server's NetBoot, because that's really easy to do. But if that support could be built into
Yeah.
BSDPy, that would make it much more
Like I
compelling
said,
for me to
it's all
switch.
based, my priorities based on what do I need and what have I never needed in my life. But I know that other people, it's the exact way around. It's I need this more than anything else. So if you have, some sort of semi-technical description of how that works or how you use it, that would be great to be able to test it out, because I don't even know how to test some of those things out without having an image that is set up to use it, et cetera. So
Okay.
yeah, I definitely would love to implement it. The more the better.
I'll open an issue.
Cool.
So the answer to this is probably test it and see, but do you have any sort of, if you were to implement each of the components, the HTTP/NFS server, the TFTP server, all on different boxes or virtual machines, do you have sort of recommendations for the equivalent performance of each piece? Like if I'm going to NetBoot an entire lab simultaneously, invariably one or two of them aren't going to NetBoot.
Right.
So what is the most critical, most powerful part of that?
I think the HTTP NFS part is going to be, so TFTP is just slow kind of regardless of what you do. So you could have multiple TFTP servers possibly, but it just serves it as fast as it can. It's UDP, so it's like if a block doesn't make it, then get it, send it again. So that's, if your network has latency, all the issues, that may be slow. HTTP, the difference with HTTP is that it needs to load the entire image before it can do anything with it. NFS, it's a mount, so it mounts the mount point and then mounts the disk image. It still needs to read data off it, but it can be quicker. But so my answer is, if you have a lot of simultaneous boots, you might want to look at NFS first, because it's a little shorter to get started. HTTP is more robust and it's easier to, deploy globally, basically. So that would be my answer.
Cool, thank you.
This might fall firmly into the dumb question realm, but is there support or easy or even complicated way to boot a non-Mac OS?
Yes.
Way?
Sam Keeley, again, name comes up. We've worked together to do PXE booting. So if you compile an EFI compatible booter, that's just called booter, but is actually the iPXE client,
Okay.
you can actually boot Linux or whatever else.
So you can hand it that in place of booter,
Yeah.
and it'll take over PXE boot.
Yeah, there's actually a project, it's offline now, but I grabbed it before it went away, that has the tool chain in it to build something like that.
Okay.
And put in like a trigger file to go get your config from some HTTP source.
So
yeah.
you can have available image. You
Yeah.
can basically choose which OS you wanted.
Yep. Yeah, that's possible. Yep. All right, well, if there's no more questions, thank you all.